In this video, we're going to start looking at ring flips, also called chair flips. So I'm going to just go ahead and draw a cyclohexane in a ring in a chair conformation. And then again, remember we have our axial and our equatorial positions. Remember also they alternated, so I just drew axial up on that position, or on that carbon, so axial would be down on this position, up, down, up, down. My equatorial positions were the opposite, so the carbon that I have up, my axial was up, my equatorial was down, up, down, up, down, up, right? Those are my only allowed positions. I'm going to draw that chair again without those bonds on there. So what happens with a chair flip or a ring flip is we're going to take the carbon that's going up and we're actually going to bend it down. The carbon that's down is going to move up. The four carbons in the middle are staying in the middle, right? Those ones are planar and they're going to stay planar. So we're just moving those two opposite carbons. And it actually goes through what's called a boat. They're not necessarily moving simultaneously. The one that's down can go up, so they're both up. Let me draw a quick picture of that. That looks like a cat. Everything looks like a cat to me. So if I want to leave that one the same, we can actually have that one come up. It still looks like a cat, but it's supposed to look like a boat. So this is coming out at us, right? We could have taken the one that was up and bent it down, and then it's just an upside down boat. It's capsized. These aren't very good. But you actually do go through a boat structure. This is our boat. I'm not going to ask you to draw boats, but do know that they exist. What we're going to do is we're just going to go from one chair to another chair. So the carbon that's up is going down, the carbon that's down is going up, and we're going to end up producing, and I'm just drawing two arrows because it's not a reaction arrow. I don't want you to think that it's reacting. It's not. I don't want to draw a resonance arrow because it's not. So just for a lack of a better arrow to draw, I'm just drawing two of them. I'm going to end up with this version. And I mentioned this before. I'm not very good at drawing this one. I usually have to draw every time I draw it, I have to do it a couple times. It's this carbon that I have issues with. If I was to number these, carbon 1, 2, 3, 4, 5, 6, and I'm just starting on that carbon because I usually do. So I started on that carbon that was up and I went clockwise. So the carbon that was up is now down. I'm still going to go clockwise. So be careful. What happens is a lot of people will actually number these incorrectly. So doing this again, this was carbon 1, so this is carbon 1, right? Carbon 1 was up, I bent it down. And then carbon 2 was clockwise relative to carbon 1. Carbon 2 is still clockwise relative to carbon 1. We did not move those carbons in the middle. Carbon 3, carbon 4 over here was down, it's now up, and then 5 and 6 are still in that same position. So those ones in the middle, right, these guys are still in the same spot. It's just carbon 1 and 4 that we're switching. I will show you some models here in a few minutes. So the carbon that's up goes down, the carbon that down goes up. It does go through that boat conformation, just know that that happens. I'm not going to ask you to draw boats. And these are conformations, right? Again, I do want us to remember the difference between conformations and different isomers, different structures, right? All I'm doing is I am rotating those bonds. I'm not rotating them 180 because I can't, right? It's a ring, but I am shifting those bonds. So these would be conformations of each other. When we do this, all of the positions that were axial become equatorial in the new conformation. all of the positions that were equatorial become axial in that new position. So I'm going to draw these again. They get a little uglier every time I draw them. But I'm going to put my axial and equatorial positions on. So up, down. I actually do want to draw this a little bit better. I assume that you guys are having to draw it a couple times also. So this gives you time while I fix it to perfect your chair conformations also. Okay, axial, up, down, up, down, up, down, right? Those are my axial positions. My equatorial positions are going to be opposite, down, up, down, up, down, up. So when we do a chair flip or our ring flip, so the carbon that was up is now down, the carbon that is down is now up. So we need to draw that one. I'm going to try to fix this. I always have issues with this one carbon. So there's a carbon there and then it goes down. So let's actually put a group on here. I'm just going to put a CH3 group. And I'm going to use pink to represent the same bonds, not necessarily axial, but the same bonds I had in the first one. So remember we had said that our axial positions are up on the carbon that's up and then down on the carbon that's down. When I go from one chair conformation, I do my ring flip to the other chair conformation, axials become equatorial. So that pink CH3 group is now actually in the equatorial position, which is up on that carbon. Axial is now green, and that's down. So let's look at that again. Maybe we'll start with the axial ones. So if I look, this is my axial position. It's green, it's down. That carbon is this carbon right here, right? That's the one that moved. All my axial positions become equatorial. So that green bond, right, was an equatorial position. It's now an axial position. If I look at this carbon, that's this carbon, right? The one I just put that bond on. The green was equatorial up. It's now axial up. This carbon, my green was equatorial down. It's now axial down. This is the carbon that's now up. My green was equatorial up. It's now axial up. This is now axial down. This is now axial up. So I will write this down in a second, but all of the axial positions become equatorial positions. And then all of my equatorial becomes axial, whatever the opposite was I just said. So this pink is now equatorial up, equatorial down, equatorial up, equatorial down, equatorial up. That's supposed to be equatorial. I just didn't give myself very much room. And then equatorial down. Try to fix it. It does slope in the direction of that carbon-carbon bond. So it does go that way, like not that way. So let's write this down. When the chair conformation undergoes, I don't know why I stuck an extra O in there, undergoes a ring flip, the axial positions become equatorial and the equatorial positions become axial. If you go and look at what we did, right, the carbon in my new one, the one on the right, after we did our ring flip, the carbon that's up still has my axial up. The carbon that's down still has my axial down. So when you go and you look for those positions, you can still start with the axial up on the carbon that's up and alternate them. It's just that before it did the flip, right, it's this one. Oop, not that one. It's this one. It was in the equatorial position. Again, be careful how you number these. Don't do what I just did. It's easy to do. So let me number these. If I make this carbon 1 and then I go clockwise, and again, you can make any carbon 1 and you can go clockwise or counterclockwise. Just make sure that you're consistent. So because I went clockwise on my first one, I have to go clockwise on my second one, otherwise I'm making something different, right? I only want to move carbon 1 and 4 in that first one that I did. So that's carbon 1, and then I have to go clockwise. So 2, 3, 4, 5, and 6. So axial positions become equatorial, the equatorial positions become axial. The other thing to note is the groups that were going up are still up, right? My pink methyl group was axial up on the one molecule, it's equatorial up on the other, right? After it does its ring flip or its chair flip. If I look at this green group on carbon 2, right, it was up. If I look at the green group on carbon 2 in the other conformation, it's still up. So axial becomes equatorial, equatorial becomes axial, but up is still up and down is still down. And by that I mean if it was pointing above the ring, it's still pointing above the ring. If it was pointing below the ring, it's still pointing below the ring. So if it was going up, it's still going up. It just happens to be axial if it was equatorial. It happens to be equatorial if it was axial. If it was going down, it's still going down. It's just switching that axial and equatorial position, right? So if I go and look, picking a different color highlighter here, on carbon 4, right, my pink group was going down. It was axial. On carbon 4, my pink group is going down, it's now equatorial. So axial becomes equatorial, equatorial becomes axial. If it was going up, it's still going up. If it was going down, it's still going down. An example, let's draw trans 1-ethyl 2-methyl cyclohexane in a chair conformation. Then we're going to draw the resulting conformation after it undergoes a ring flip. Then we're going to choose which one is more stable. Remember, more stable means lower in energy, so which is lower in energy? And then of course we're going to explain why by identifying strain. So if you want, you can draw just the planar one again to start. You don't have to. You can go right to the chair if you want. I do know that I have a 2-carbon group on 1 carbon, and then an adjacent carbon, I have a 1-carbon group. And again, you can make any carbon 1, and then next to it is going to be your 1-carbon group. You can go clockwise or counterclockwise, it doesn't matter. This one does say that it's trans, so I know one of those groups is coming out, and then the other group is going to be going back. And it doesn't matter which is which, I just need to have them on opposite sides of that ring. So since I choose to put my ethyl group coming out at us, I had that methyl group going back. if I wanted to draw it, and again, you don't have to draw any of these because the directions aren't asking. I'm just making sure we can all picture what's going on. If I wanted to draw the ring going this way, I could put my methyl group, my ethyl group going up and my methyl group going down. Again, however you want to do it, that's a 2. Make sure you're attaching to your carbons, not your hydrogens. So I always, even now, sometimes I just do it in my head, but I always sketch. And it's just kind of messy. And this is okay if it's messy because it's not going to be our answer. It's just our work. So up, down, up, down, up, down. Because we want to make sure we put stuff in the right position. Up, down. Oop. If the first one's up, down, and the second one's down, up, right? Down, up, down, up, down, up. So that again, if you're doing this on paper, that's kind of your work. It's in the margin. That's not going to be my answer. I couldn't, because right now, without attaching anything to those are all methyl groups, right? If I was to go and let's say put my ethyl group here, and then put my methyl group here, and then turn that in, I'm going to lose a ton of points. Because remember, if I'm drawing skeletal structures, which when I don't put carbons on my ring, right, I am, all of these things right here are methyl groups. I did not draw, right, trans 1-ethyl 2-methyl cyclohexane. I drew, I guess I have 12 methyl groups on there. So whatever the prefix is for 12, right, instead of dimethyl, di is 2, I would have 12 methyl. 11 methyl in 1 ethyl group. But anyway, that's not, don't do that, right? If you want to put your groups on there and then erase the other groups, you can, that's fine. You don't have to redraw it, but don't leave all of those bonds there if they're to hydrogen. Or if you wanted, you have to go and put hydrogens on all of these, right? If you put hydrogens on them, you're fine, but don't leave them as methyl groups. Okay, I'm just gonna use it as my key. So I'm gonna draw my chair. I like to make this carbon 1. I've noticed that a couple times. So I'm going to make this carbon 2. Since I'm going to do a chair flip, it doesn't matter how I start. So I'm going to start with my ethyl group going up. You can write CH2, CH3, or you can just use skeletal structures. It doesn't matter. Since I want trans, remember trans means if one's up, the other's down. So since I put my first group here, and I'm making this carbon 2, since that is axial up, my methyl group is going to be axial down. So that's my methyl group. You can write CH3 if you want, or you can just leave it as skeletal structures. If I would have done, this instead of this one, now I drew cis because they're both up. Remember, cis and trans don't tell me if they're both axial, equatorial, or one of each. They tell me whether they're both on the same side of the ring or opposite sides of the ring, right? If I look at this is going up, this is going down. I have this up, I have this down. So trans means they're going on opposite sides of the ring. So that's my 1. I'm then going to do my chair flip. So carbon 1 is going to go down. If I was to finish numbering this, this is 3, this is 4, 5, and 6. Carbon 4 is going to go up. 2, 3, 5, and 6 are going to stay how they are. And we're going to draw this. It'll probably take me 3 tries because it usually does. That's actually not too horrible. So this is carbon 1. Be careful. And then this is carbon 2, right? I took this carbon and I moved it down, so that's this carbon. 2 is still clockwise to it, so don't change that. That's one of the #1 mistakes, besides getting cis and trans backwards, thinking it means they both mean axial or equatorial when it doesn't. Numbering them wrong. And if you number them wrong, you're putting the groups on the wrong carbon, right? I don't want you to draw an isomer of this. I want you to draw the same structure when I move one carbon down and the other carbon up. So now I have the 2 carbons, 1 and 2. I know on carbon 1, I had an ethyl group that was going up, and it was in the axial position. It's now going to be equatorial, because axial becomes equatorial, but it's still going to be going up, right? Up stays up. So it was axial, it's going to be equatorial, but it's still going to be going up. So that's going to be that group. On carbon 2, I'm going to have to move that letter out of the way because it's going to be in my, or that number out of the way because it's in my way. On carbon 2, I had my methyl group going down. It was axial, so it's now going to be equatorial because axial becomes equatorial. It was going down, so it's still going down. And it does need to be sloped. It's not really attached to that carbon, is it? So down. So that would be the structure that I get when it undergoes the ring flip. So this is my, when it says to draw in a chair conformation, I chose that one. There's a variety of different things you can do. The important thing is that you have the ethyl group and the methyl group on adjacent carbons, whatever ones you decide to make 1 and 2. And one has to be going above the ring, the other has to be going below the ring. And then these are your options for positions. So if I wanted to put ethyl here, I could have put methyl here if I wanted. And that would be perfectly fine. They're on adjacent carbons, one up, one's down. So that would be perfectly fine. There's a lot of options for you, but they have to be in those positions, right? Those pink and blue positions. There aren't other options. It underwent a chair flip, and this is what I get, right? If I wanted to finish numbering it, again, that's probably one of the things that folks get wrong. Those are those carbon numbers. This is my methyl group. Oop. Wanted the highlighter, right? It was down, it's still down, was axial, it's not equatorial. My ethyl group, it was up, it's still up, was axial, it's now equatorial. So of these two, which one's more stable? That's our next question. So molecule A or molecule B? Which one are you guys thinking? I'm gonna pick B. Hopefully you guys did too. This is our more stable one. Why are we saying this? Those that got it, what was your thinking? Yeah, group, right? We have less steric strain. When the alkyl groups are equatorial, right? We're avoiding our 1,3 diaxial interactions. And be careful, like this is totally a question I would ask, and I would ask you to give that explanation also. And don't just say it's more stable because the larger groups are equatorial, because then I'm gonna say, well, why does that make it more stable? I wanna know that you know that it has less steric strain. So less steric strain is important. If you don't say that, you're gonna lose points. So if you just say larger groups are equatorial, I'm gonna be like, so why does that matter, right? It matters because it has less strain that way. So larger groups kind of pointing out to the side versus causing strain with whatever group, steric strain with whatever group is 3 carbons away, right? We're gonna have some strain between that hydrogen and that methyl group. There's a hydrogen here in that methyl group. And then this ethyl group, we forget what it looks like when we draw skeletal structures, but it's pretty big. And then this bond between the 2 carbons also rotates. This bond rotates, so that whole thing kind of swings around. And I got a hydrogen right here it can interact with. I also have a hydrogen right here it can interact with. So that's a mess now, but that molecule is a mess, right? It has a lot of steric strain going on. By pointing them out around the outside, right, I can minimize that. Okay guys, so let's look at the model. So we have our chair here, it's kind of messy, but I do have my white positions as my axial positions and the green atoms are in my equatorial position. So this carbon right here is the one that's up. It is kind of hard to see when I have all those groups on it, but that carbon's up. These 4 here are, you can see, because now you can only see my hand, but those 4 are in the middle, and then that carbon's going down. So what I'm going to do is I'm going to take this carbon and I'm going to bend it down. I'm going to take this carbon and bend it up. So this one's going down. Now I have a boat. This one's going up. And let me get it all finalized. And if I look, my green positions are now my axial positions and my white positions are now my equatorial, right? What was axial is now equatorial. What was equatorial is now axial, right? We'll flip it back. So my green ones are my axial positions, my white ones are my equatorial, right? They're pointing out around the outside. I'm going to do a chair flip. Try to do them both at the same time that time. And my white ones, right, are now axial. My green ones are now equatorial. So when we do that chair flip again, whatever was axial becomes equatorial. I'm going to do another one with just the 2 groups on it. And I'm going to put a methyl group. Let's actually just do 2 methyl groups. I would make the ethyl, but I don't have one pre-made, and this will work. So if we're doing that 1,3, so I'm going to make this carbon 1. So on carbon 1, I had that going up. I guess we had carbon 1, 2, sorry. And then this is my group on carbon 2. So this was we had an ethyl group here on the example that we used, but I'm doing 2 methyl groups instead. So I have them trans, right? One's going up, one's going down. They both happen to be axial, but that's just because I have them on adjacent carbons. If I had 1 and 3, then one would be axial and one would be equatorial to get them trans. Again, remember, trans just means they're on opposite sides of the ring. So if one's up, the other's down. I'm going to do a chair flip now. I'm going to take this and bend it down. I'm going to take this and bend it up. And when I do that, those groups are now in the equatorial position, right? What was axial becomes equatorial. And let's do one more where they're different so you can see that what was up was still up. So I have them both axial right now, right? Straight up, straight down. The green one is up, right? Remember, we want to say up is still up. So after I put this in, after I do the chair flip or the ring flip, this is still going to be up. It's just going to be equatorial instead of axial. So green is up. That's what we're focusing on. They're both axial. So that carbon goes down. This carbon goes up. They're now both equatorial. It's not a very good chair flip here, but they're both equatorial. And if we look, the green is still up. This one is still down. The angle that I was showing you, it looked like it was axial, but it is equatorial. So down is still down, up is still up. Axial becomes equatorial. Equatorial becomes axial.